Hi, I'm Mr. V, and this is lesson 7, Applying Ratios in Right Triangles, from Unit 4, Right Triangle Trigonometry, of our text illustrative mathematics. And the objective today is that you will be able to say, I can use sine, cosine, and tangent to find the height of an object. To start this lesson, instead of doing the bell work, which is to do this problem, I'm going to start by going through some of the homework problems, which will show us how to do these, how to approach these problems. And this particular one, it says, select all statements that are true. Now, I'm going to draw on this. SOHCAHTOA. The sine is the ratio of the opposite of the hypotenuse. Ka, the cosine is the ratio of the adjacent over the hypotenuse. And toa, the tangent, is the ratio of the opposite over the adjacent. We have these angles here. This one is called theta. It's not a 0. It's not an O. It's a letter, a Greek letter, which is like an O with a line through it. You can think of it as an H, theta. It's degrees. And this one we call beta degrees, which is like a B, only it's got a little tail on it. These are Greek letters. We use Greek to name the angles out of honor to the Greeks who gave us geometry. So if we look at the sine of this angle, so this is my reference angle, sine is the opposite over the hypotenuse. That would be 4 over 90, square root of 97. This is true, 4 over square root of 97. From tangent B, from this angle, the tangent is the opposite over the adjacent. That would be 9 over 4. This would be true. It is not 4 over 9. That would be the tangent of theta, not beta. And theta, beta, don't get confused. You could just call them x and y, but we're going to honor the Greeks. So we're just going to call it theta and beta. It's just a symbol. But notice the difference here. This one is like an H, kind of. This is like a B. The cosine from this one. Cosine is the adjacent divided by the hypotenuse. That would be 4 divided by the square root of 97. Oh, that's true. And how about a squared plus b squared is equal to c squared? This is 97. It doesn't say 97 squared. Well, I have the square root of 97. And if you square that, what do you get? You get 97. So this is true as well. Okay. On this triangle, write an expression that can be used to find JH. Let's call this X instead of JH. And GJ, we'll call this one Y. So we want an expression for these two. First thing I do is I write SOHCAHTOA. Why? Because this will help me to remember as a memory aid what the ratio is that I'm going to be using. The second thing is I'm going to go from this reference angle. I'll label the hypotenuse, the opposite, and the adjacent. Now, it doesn't say that you have to find, does it say write an expression to be used to find this, and then find it? Okay, so we are going to use, since we know the hypotenuse, we'll use this ratio and this ratio. I'm not going to use this one because then I would have two unknowns. I wouldn't know anything, but I'll use these two ratios. And I'll write the sine of the degrees, 35, is equal to the ratio, opposite over the hypotenuse. The opposite is x, the hypotenuse is 9. To solve this, I multiply both sides by 9. And I can plug this value into my calculator, which will give me the value of x, because these cancel. To solve for y, the cosine of the angle of 35 is equal to the adjacent leg, y, over the hypotenuse, y over 9. Again, to solve, I'm going to isolate this variable by doing the inverse operation. We'll multiply on both sides. And this is a value you can plug into your calculator. I'm not going to do it here because you can do it on your calculator. Okay, I'll do it here just to show you how this works. I go to my Desmos graphing. I have 9 times the cosine of 35. 9. And if I multiply that times the cosine of 35, I get a number, 7.4. So y is equal to 7.4. You see how that's a number? It's not 35. It's the cosine of 35 degrees, which would give me a number. Andre and Claire are discussing triangle ABC that has a right angle at C. So I'm going to draw a picture of this. Here's C and A and B. Andre thinks that the Oh, the hypotenuse is 15. He thinks that the legs could be 9 and 12. And Claire thinks that the angle could be 20 degrees. Could be 20 degrees and 14.1. Which of them, if either or both, are correct? Well, to check these sides, if they are truly a right triangle, it would have to be true that a squared plus b squared is equal to c squared. If that's true, then these are the correct sides. So 9 squared plus 12 squared, is that equal to 15 squared? 9 squared is 81, 12 squared is 144, and 15 squared is 255, or 225. So yes, it does work. So Andre is correct. Let's check on Claire. For Claire to be correct, to say that this side is 15, this would be, I'm going to do SOHCAHTOA. SOHCAHTOA. I'm given this side. This would be the adjacent. This is the way that you would approach this. Adjacent, the hypotenuse, and the opposite. Now, we don't know these guys. She's saying that if this is 20 degrees and this is 14.1, then this would be 15. So you know the adjacent and the hypotenuse, which would be this ratio. So we should be able to say the cosine of 20 degrees is that equal to 14.1 divided by 15. 14.1 divided by 15 is 14.1 divided by 15 is about 0.94. And is that equal to the cosine of 20? Well, the cosine of 20 is about 9.4. So yes, they're both correct. So Claire is also correct because this ratio is equal to this ratio. You see how that works? Then we have this guy. The triangle has sides with 5, 12, and 13. Verified as a Pythagorean triple. If it is a Pythagorean triple, then a squared plus b squared is equal to c squared. So 5 squared plus 12 squared, is that equal to 13 squared? And do you recognize this as a Pythagorean triple? You probably should recognize it as a Pythagorean triple. Yes, it is true. 13 squared is 169. Approximate the angles that have the following quotients. Adjacent divided by hypotenuse, this one, of 0.96. It's going to be about 15 degrees. Opposite divided by hypotenuse, 0.46 would be somewhere between here, maybe 25 degrees. Adjacent divided by the hypotenuse is 0.309. That's going to be between 70 and 80, maybe 75, I don't know. Opposite divided by adjacent, this leg, 1.036. It's going to be between here and here, so that'd be between maybe 45 degrees. And now Tyler and Lynn was helping this class, Tyler's helping her. And so they use the ratios that are provided in here. And I'm going to only look at this one, which is the same as this one. So 573, somewhere between here, maybe 55 degrees. And 0.819 will be between here. That may be 35 degrees. And notice these two add up to 90. These values are the same because if I have an angle and this is A and this is B and this is C, the opposite divided by the hypotenuse from this angle is the same as the adjacent divided by the hypotenuse from this angle. So these are the same. And last we have this one, find the value of each leg. I'm going to draw my 30, 60, 90 right triangle over to the side, which is the hypotenuse is double the shorter leg, and this would be the square root of 3 times that. Since this is 4, this would be 2, and 2 times the square root of 3. And now for our lesson. For the lesson today, the very first activity that I have you doing is trying to find the missing sides, AC and BC. And to do this, I'm just going to label this X and Y. And I'm going to do that because I want to use short. I don't want to write out AC, BC every time. I'll just write X and Y. First thing we do, SOHCAHTOA. Why do I do this? Because I want to remember and get the ratios correct. These are each ratios, a sine, cosine, and tangent, the trigonometric ratios. That's what they call these. And then I'm going to label my drawing. And I'll label this from this reference angle. This is the hypotenuse. This is the opposite. It goes all the way across. And this is the adjacent leg. And now I can set up the ratios and solve the problem. So we have the sine of the degrees, sine of 20 degrees, is equal to the opposite, x, divided by the hypotenuse, which is 6. I'll cross multiply, and I get 6 times the sine of 20 degrees is equal to x, and I can plug this value into the calculator and solve for x. To solve for y, I know the hypotenuse. Remember, I know this one. I know the hypotenuse, so I'm going to use this one to find y, the adjacent. The cosine of 20 degrees is equal to y over 6. Cross multiply again. 6 times the cosine of 20. This is not 20. It's the cosine of 20 degrees. And this is a number. It's like a fraction. It's a really small number. So this is going to give me my y value. And I can plug this value in to my calculator to get it. For the next part of the activity we had a problem card and a data card. And we did the info gap. So, for example, the one person says, with the data card says, he has this information. The person with the problem card can't see this. You have to come up with this on your own. So what specific information do you need? I need to know, is there a right triangle? Why do you need that information? Well, if it's a right triangle, maybe I can solve for the sides. I have the information that it is a right triangle. Okay. What specific information do you need? I need to know which angle is the right angle? Why do you need that information? I need that so that I can know how to draw the picture. I have that information. Angle C is the right angle. So angle C goes here. That means that A and B must be here and here. What specific information do you need? Can you tell me the length of side AB? Why do you need that information? That's what I'm trying to find. I don't know that information. Well, I'm trying to find this one and this one. So obviously he's not going to have them. What specific information? Can you tell me the length of AC? Why do you need information? So that I can calculate AB and BC. And I have that information, and it is 4. And maybe you ask for angle B, and we don't have angle B, but we do have angle A, which is 42 degrees. And with this information right here on the drawing, you have enough to be able to solve it. And we can do this by writing SOHCAHTOA. So, ka, remember these are ratios. Toa. Toa. A. Then I'm going to label my drawing. I'm doing this kind of in order. Yeah, I'm doing this so you can know how to do this. From this angle, this is the hypotenuse. This goes all the way across. This would be the opposite, and this would be the adjacent. And now I can set up the ratios using my sine, cosine, and tangent. Which one am I going to use? Well, I know the adjacent. And so I'm going to use this one. I'm going to use this one to find the opposite and the hypotenuse. So the tangent of 42 degrees is equal to, tangent is opposite over the adjacent. That's opposite over 4. O over 4. And multiply both sides by 4. And I get the opposite side is 4 times the tangent of 42. And I can plug that into my calculator. To find the cosine is going to be a little bit harder. The cosine of the degrees is equal to the ratio, the adjacent 4 over the hypotenuse, which should be 4. Actually, I should call this x. This is x, my x value. If I call this x here, and this is y. 4 divided by y. Now, here, if I cross multiply, I get y times the cosine of 42. Notice how I put this in parentheses. I'm doing this as a good example for you. And I'll divide both sides by the cosine of 42. And I can plug this into my calculator to get the value of y. And it should be longer than 4 because it's a hypotenuse. We did a second one of these, and in the second one, let me just pull it down here. In this one, what specific information do you need? Again, is one of the angles a right angle? Why do you need that information? Because I need to solve for the sides. And so, yes, I have the information angle E is the right angle. Or maybe you ask for the hypotenuse. What is the hypotenuse? And you said DF is the hypotenuse. So I know that E is the right angle. We know one of the sides. How do I know which one? Well, because you're asking for it. What do you need to do this? Well, you need one of the sides and one of the angles. Angle F is 71. So this is 71. I'm not drawn to scale, of course. And I can use this information to solve this. So I'll copy this over to my whiteboard on the next page. And I want to show you, again, how to do this. To do this, the first thing I do is write SOHCAHTOA. Because this tells me what the ratios are. So I don't have to remember it. I just remember SOHCAHTOA. I can do that. From this angle, this is the opposite. This is the hypotenuse. And this is the adjacent. Now, I don't like having to write out A, D, B, C. I'm just going to write X here and Y here. That'll make my shorthand easier when I go to actually solve this. What do we know? We know that the opposite side, this one, we know this for both of these. So I'm going to use these two ratios. When I write the sine of the angle, sine of 71, is equal to the opposite over the hypotenuse. The opposite is 5. The hypotenuse is, I should call this one Y. Y. To find the tangent of the degrees of 71 is equal to the opposite over the adjacent. So that would be 5 over x. And I'll leave it to you to solve these. Cross multiply, isolate the variable, and you can do this. You should get y is equal to 5 divided by sine of 71, and x is equal to 5 divided by the tangent of 71. You should try this on your own. Next, we had a couple of questions here. If you're standing on the bottom 250 feet away, can you find this height? And we could call this y. Notice this is the opposite. This is the adjacent from that angle. So if I take that angle and I do the tangent, which is my SOHCAHTOA, opposite and adjacent, the tangent of 73 is equal to y over 250. And then I solve for y. Here, tallest masonry building in Philadelphia. If you're standing 1,300 feet away, so I'm here, I'm 1,300 feet away, and you look up at a 23-degree angle, how tall is the building? So what is my y value? Again, we do the tangent because it's the opposite over the adjacent. So, and you can write out SOHCAHTOA if you wanted to. The tangent of 23 is equal to the opposite, which is y, divided by 1300, cross multiply and solve for y. You're sitting on a ledge 300 feet from a building. This is 300 feet. You have to look up at a 60-degree angle to the top of the building and down 15 degrees to see the bottom of the building. And it wants to know how tall is the building. Well, this is a 30, 60, 90 right triangle. And if this distance is 300, remember I'll draw it sideways like this. I'll draw it like this. Here's my 60 degrees, my 90. The hypotenuse is double the shorter leg. Knowing this will keep you out of trouble. This is going to be root 3 times whatever that is. So this distance here would be square root of 3 times 300. And I can plug that into a calculator to get this distance right here. And to get this last distance, this is going to be the opposite side. And this is the adjacent side of this angle. So SOHCAHTOA I'm going to use the tangent. It's the opposite, the adjacent. So the tangent of 15 degrees is equal to the opposite, which is what I'm looking for. Call this y over 300. So I can solve for y and add this piece to this one, and then I get my answer. This is this one, and I add this one here to this one. Finally, the last piece of this is this redwood. It's the tallest redwood in the world. It's like 380 feet. We're supposed to calculate it using our triangle. And you can do this using trigonometric ratios. You can also use this using a 30, 60, 90 right triangle. So this is going to be whatever the short leg is. This is y, 2y, and y times the square root of 3. So this will be 220 times the square root of 3. 1.7 times 220. Let's just see what that is. 220 times square root of 3. 381. Hey, how about that? 381. 380. That's way up there, folks. That's really tall. If you're standing in the wind at the top, that's tall. So good luck and success.